Hey guys, let's quickly go through this problem of the day from analytic geometry. And the question is, one side of a square lies along the straight line 4x plus 3y equal to 26. The diagonals of the square intersect at the point minus 2, 3. And our first question is to find the coordinates of the vertices of the square. So one good thing to do about questions like this is always to plot information given to you to scale, so that you can reason along the line and get your answers easily. So we have that 4x plus 3y equal to 26. We would want to plot this line, and we can easily use the intercept of this line to plot. Now when x equals 0, we can see that y is equal to 26 over 3, which is 8.6, and that gives us the point 0, 8.6. Also, if we plot y equal to 0, we have x to be equal to 26 over 4, which is equal to 6.5, and that gives us 6.5 against 26, against 0. And we plot these 2 points. I would want to plot them to scale, so let's use a scale of 4 on the x-axis and a scale of 4 on the y-axis also. So we have 0, 8.6 on the x-axis. We could indicate that somewhere here, and we have 6.5, 0. We could indicate that somewhere here. So I'll just draw a line to pass through these 2 points, and we can have something like this. Alright. And we're also given that the diagonals of the square passes through the point minus 2, 3. So I will try to plot minus 2, 3. We can have minus 2 somewhere here and minus 3 somewhere here. So the point comes somewhere here, right? So I'm going to try and draw a square around this point such that this point is going to be in the middle of the square, because the diagonals intersect at that point. That means that point is the middle of the square. So I would have something like this, and something like this, and also something like this. So this is my square, and I'll join the diagonals, something like this, and something like this. Okay, I would want to label this square with A, B, C, and D. That's alright. Let me put the D somewhere else. So C and D. Now we have that this line 4x plus 3y equal to 26 is one of the sides of the square, and that implies we can find its gradient by putting it in the form of y equal to ms plus c. So we would have y to be the same as minus 4 over 3 plus 26. I've basically made y the subject, and this implies that the gradient of this line, I'm going to call the line AD because it is on the line AD for the square, and that means the gradient is minus 4 over 3. So we were basically imitating y equal to mx plus c, where m is the gradient. Now another interesting thing about gradient is that any line whose angle to the x-axis is known can have its gradient known with respect to the angle. So the gradient of a line can also be given in terms of the angle it makes with the x-axis from the idea that the gradient is the same as tan of the angle it makes with the x-axis, right? So in this case, we can also have that if the angle here is theta, then we can have that the gradient of the same line AD is equal to tan theta, which we have found as minus 4/3 for the mean time. And we actually need this information because so far we only have the equation of the line given in the question, and we also have a point from the line AC and the line BD, and we are to solve the the vertices of all the square. And one of the ways to do that is to solve two lines simultaneously. And the only line we know so far is AD, so we would have to make sure we know another line from AC or BD so that we solve them simultaneously. And because we already have a point on AC, we can try finding the gradient of AC, and we can do that by comparing the angle it makes with the x-axis to that of the other gradient. So I have here as theta already. I'm going to indicate the angle AC makes with the x-axis and call it alpha. And because the interior angle of a square is 90 degrees, and we have that the line AC is the diagonal, it means the line AC intersect or bisect actually the angle at A into two equal parts. So we can have here to be 45 degrees. So given this, we can have the triangle. So I can actually call the point here maybe E, and I can call the point here maybe F. So basically from triangle AEF, it implies that the angle 45 degrees plus the angle alpha is equal to theta. This is from the idea that the sum of the two opposite interior angle is equal to an exterior angle. Yeah, so we can borrow that idea from the fact that if we have a triangle of this caliber where here is A and here is B and here is C, then we have that A plus B is equal to C. That is what we just used for this expression here. So we want to use that idea, given that we know the value for tan theta here to be this. We want to use that idea to find the value for tan alpha, and of course tan alpha is the same as the gradient of AC. So I can write that here. So M of AC is actually the same as tan alpha. So we basically want to find tan alpha, hence why we initiated this angle equation. So I'm going to make tan alpha the subject from what we have there. So therefore, I'm going to make alpha the subject. So therefore, alpha is equal to theta minus 45 degrees. Sorry, I just made a mistake. Alpha is equal to theta minus 45 degrees. I now apply tan at both sides, so I have tan alpha is equal to tan theta minus 45. And here I apply the double angles property. So tan theta minus tan 45 divided by 1 plus tan theta times tan 45. But remember, we have the value of tan theta. Tan theta is equal to, just as we have here, minus 4/3. So, and from normal evaluation, we have tan 45 to be equal to 1. So we just evaluate it at minus 4 over 3 minus 1 over 1 plus minus 4 over 3 times 1, and everything here will give you 7. Yeah, so from here it means we have tan alpha to be equal to 7. That means the gradient of the line AC is equal to 7. So finally we can find the equation of the line AC, right? So therefore the equation of line AC is, we just quote the formula, y minus y1 equal to the gradient of AC into bracket s minus x1. And remember that there is a point on AC, that is a point where the two diagonals intersect. That is one of the points on AC, and that point is actually given as minus 2, 3. So we have every information. Therefore y minus 3 equal to 7 s minus minus 2, which finally gives us y minus 7x equal to 17, right? After evaluation, that is what you get. Then we try to solve them simultaneously. So this is actually our equation 1. And remember, we already have one equation from the AD, which was given in the question. So that is it here. So we are basically solving the equation AC and equation AD simultaneously. And that is going to give us the point A. Yeah, it's going to give us the point A. So we solve AC and AD simultaneously, and doing that is, I'm going to quote them. We have y minus 7x equal to 17, and from the question it was given that 4x plus 3y equal to 26. So we solve these two, then we get x equal to minus 1 and y equal to 10. So that gives us the point A to be equal to minus 1 and 10. Now we have the point A, right? This is now minus 1 and 10. We are to solve another point, but we can easily use the midpoint formula to find the point at C, right? Because we have a point on A and we have this point here. Remember that the 2 points bisect each other, and they bisect each other at the midpoint. So on the line AC, the point we were given, which is the minus 2, 3 point, is actually the midpoint of both AC and BD. So since I have 2 points on AC, I can use the midpoint formula to find the point at C, right? So I'm now going to let C be represented by RS. So since minus 2, 3 is the midpoint of AC, it implies that minus 2, 3 is going to be, so we use the midpoint formula, that is x1 plus s2 over 2, y1 plus y2 over 2, and we have everything already, so we just substitute. That is giving us s plus 10, that is r minus 1 over 2 and s plus 10 over 2. So we just compare them one after the other. So 2 minus 2 matches r minus 1 over 2, and 3 matches s plus 10 over 2, right? So from here we have r to be equal to minus 3, right? R to be equal to minus 3, and we have s to be equal to minus 4, right? Minus 4. So therefore C, which was rs, is actually minus 3 minus 4. So far we have two of the points. Now another interesting thing is we know that BD is perpendicular to AC. When we go back to the diagram, we know that BD, that is the two diagonals, are perpendicular. I can indicate the perpendicular sign there. So since the two diagonals are perpendicular and we know the gradient of AC, we can find the gradient of BD, right? So we just found the gradient of AC to be tan alpha, which we had as 7. So we can find the gradient of BD as minus 1 over 7. So we know that since BD is perpendicular to AC, it implies that the gradient of BD is equal to negative 1 over the gradient of AC, which is negative 1 over the gradient of AC was 7. Thus the equation of BD becomes, so this implies the equation of BD, which we have as a formula to be y minus y1, then the gradient of BD times x minus x1. Remember, BD also passes through the points we were given from the question, that is minus 3, minus 2, 3. And we have the gradient also to be minus 1 over 7. So by substituting, we have y minus 3 equal to minus 1 over 7 x minus minus 2. So finally, we have the equation as s plus 7y equal to 19. After you take your time to evaluate, you get this. And why do we need the equation of BD? Because we can now solve BD and the equation we were given in the question AD simultaneously to find D, right? So we solve BD and AD to find D. So I quickly come and see. We solve BD and AD simultaneously to find D. So BD we just found as s plus 7y equal to 19, and we already knew AD from the question as 4x plus 3y equal to 26. So solving them simultaneously, you get x to be equal to 5 and you get y to be equal to 2. Then finally, it means D is equal to 5, 2. We are left with the last point to solve, which we are going to use the midpoint idea again. Remember, this time we know D to be 5, 2. We know the midpoint here. So we just have to find B. We probably can represent it with AB. So given the midpoint formula, we can now solve for D. So let's maybe D, we are finding b, so let b be AB, just like we said for the other one, right? So if b is AB, then since BD, since minus 2, 3 is midpoint of BD, it implies that minus 2, 3 is equal to S1 plus S2 all over 2 and Y1 plus Y2 all over 2, where we know the point for B to be just AB, but the point for D is known to be 5, 2. So we substitute and we have A plus 5 over 2 and B plus 2 over 2 against 2 minus 3. So we compare and have minus 2 is equal to A plus 5 over 2, and we have 3 is equal to B plus 2 over 2. Finally, we have A to be 9 minus 9 actually, and we have B to be 4. So that implies that the point B of AB becomes actually minus 9 and 4. So we found all the 4 points already, but there was a second question that we had to solve. The question says that find the equation of the two sides of the square which are perpendicular to the given line. And if you look at the given line, which is this line, they are perpendicular. The two lines that are perpendicular to those two, that given line is the line BA and the line CA. So this line and this line are perpendicular to the given line. So we have to find the equation of the line AB and the line CD, right? So we quickly go through that. And because they are perpendicular means the gradient of those two lines are the negative reciprocal of the gradient of the given line. So we'll quickly go through the gradient of the given line. So B, AB and CB are the perpendicular lines to the given line, which we know as 4x plus 3y equal to, that is to the given line, equal to 26. So we have to find the equation of both AB and CB. So this implies that the gradient of AB is going to be equal to the gradient of CB, which is going to be negative 1 over the gradient of the given line. Remember, the given line is actually AD, right? And that is going to be minus 1 over minus 4 over 3. And that is going to be 3 over 4. So we take them one after the other to find their equation, right? So the first one, that's the equation of AB. The equation of AB is going to be y minus y1 is equal to the gradient of AB divided by times x minus x1. Remember, we can use any of the points A or B to represent x1 and y1. So let's say we are using the point A, and the point A was one of the first points we solved, which was minus 110, right? So by substituting, we have y minus 10 is equal to the gradient we just solved, 4 over 3 and x minus minus 1, which finally gives us 3x minus 4y plus 43 over m is equal to 0. Also, the equation of the line CB so it's actually CD, not CB. Yeah, so CD is what we have been talking about as being perpendicular to the given line CD. So the equation of the line CD is equal to y minus y1 equal to m x minus x1, and we can use either C or D point, but we will stick to just the C point, which was minus 3 minus 4, right? So finally we have y minus 4 is equal to 3 over 4 into bracket s minus 3, right? And that is going to be finally 3x minus 4y minus 7 equal to 0. Yep, so that ends the solution for this question. See you another time.